Scientist, humanitarian, Nobel Prize winner, colleague, friend. There were many ways to identify Dr. Michael Smith, a distinguished and creative scientist, a humble man known for his humanity. He gave generously to the people of Canada and the world, using his time, energy, and willpower to spread the message of science and its importance to everyone's life. Born in England in 1932, he received his PhD in 1956 from the University of Manchester and then undertook his postdoctoral studies in Gobind Khorana's laboratory in Vancouver, Canada. Dr. Gobind Khorana was also a Nobel Prize winner in 1968 for work on the genetic code, being the first scientist to demonstrate the role of nucleotides in protein synthesis. Dr. Smith would often say that this man would be his greatest inspiration in life and science. After leaving Khorana's lab in 1961, Smith later moved to the University of British Columbia and developed his famous technique there, site-directed mutagenesis. Site-directed mutagenesis is the process of selecting a specific DNA nucleotide to alter, then designing a primer that anneals to that strand of DNA, and making millions of mutated plasmids using PCR, a type of biomedical technology. Once this has been established, the newly multiplied plasmid is transformed into a host bacterial cell that will then reproduce on a large scale and show the effect of the mutation. This very process is now considered a standard technique in biochemistry and has been used in various contributions to the field. One of its most significant accomplishments is that it has been used to develop human insulin from bacteria through yeast. It has also highly advanced the study of genetic illnesses such as Parkinson's, Alzheimer's, and many more.
If you could design one little bit of DNA that you'd made in a test tube, it should complement a naturally occurring piece and allow you to isolate it out of the mixture of thousands or tens of thousands of other nucleic acids. We knew that we could form a little double helix where one strand was, say, a piece equivalent to a piece of DNA, and the other strand was the true complement of that, but in the middle of that, there was something that was wrong, and yet you would still form a double helix.
During his many public appearances, Dr. Smith often spoke about the taboos and myths surrounding genetic engineering at the time.
I think people have to realize that humans as a society have been breeding things for their own good since society exists. I mean, we've been breeding animals to provide food. We've been breeding animals for work. We've been breeding animals as pets. It's not new. And the thing that has concerned me that has been the tendency to say, oh, genetic engineering has created all these things as new activities. But in fact, if you reflect on things, they're not.
In 1993, Dr. Michael Smith received the Nobel Prize for Chemistry for his development of the technique of site-directed mutagenesis, along with American Dr. Kary Mullis. He donated half of his Nobel Prize money to researchers working on the genetics of schizophrenia, a widespread mental disorder for which research money is scarce. The other half he gave to Science World BC and to the Society for Canadian Women in Science and Technology.
Several people are involved in doing it, and yet the prize isn't shared amongst all of them. You try and share it as much as you can by taking them to the thing, but obviously that doesn't actually give them the prize per se, and you can't do anything about it. I participated in work that two other people won Nobel Prizes. I never felt that I wanted to share in it, in this sense. I was just happy that it happened to them, so I hope my colleagues feel the same way about their relationship with me. I guess the downside of it, which I try and avoid falling into, is a trap of people look on you as somewhat different, that you're wiser than other people, that you're an expert on all sorts of things. And of course, you're not. You know a fair bit about your area of science, and you've been lucky enough to do a crucial experiment or make a crucial discovery earlier than other people perhaps would have done in that area of science, but otherwise you're just a normal human being, and you shouldn't allow yourself to let other people think you are, allow yourself to think you're anything more than that. Otherwise I think you could get into trouble.